So for the experiment 3, we will be exploring ensemble method, and I use boosting, voting, and stacking ensemble methods. Starting with the boosting, we use the AdaBoost classifier. Boosting is basically draw attention to the instances that previously misclassify, allowing that the subsequent models to learn from the errors made by the previous model to improve the model performance metric. So how it actually works. So first, an equal amount of weight will be applied to all the training data, and then the algorithm starts by training the weak classifier and then weighted according to how well it performs. So the correctly classify are weighted less, and then misclassify instances are weighted more. Then the algorithm will change the second weak classifier using the weighted data, and this process will be repeats for a given number of iteration or until the error rate below the threshold. And this is the result we obtained from the boosting ensemble method. So when compared with the baseline model of the data set, which achieved an accuracy of 50%, the boosting ensemble method performs better, as it may be because of it focuses more on improving the classification with that misclassified instances. So for the voting, how this voting works is first, we need to train the base classifiers, which are the logistic regression, Bernoulli naive Bayes, and decision tree separately and generate its own predictions. And then only we will be using the voting classifier for. At this place, we set the voting method as hard, which means the voting classifier predict the class that received the most votes by averaging the prediction made by each classifier. So in this case, we have two classifiers predicted as 1 and 1 is 0. So considering the measure vote, the final prediction will be 1. And the voting result. So from this, we observe that the performance metrics of voting classifiers similar almost similar to one of its base classifier. This is because of data set is being balanced, where almost equal number of instances in each class. So if we use this ensemble method for a balanced data set, voting classifier accuracy may closely with the accuracy of its base classifiers. So, and then for the stacking part, stacking will combining the multiple models assigned to create a meta model that learns successfully integrate the various prediction of the base models. So to explain more same as the voting ensemble method, we use the same three classifiers and then we train it separately, and then the base models makes a range of prediction based on its respective algorithm learn patterns, and these predictions are the input features for the subsequent meta classifier. And in our experiment, we use the KNN, which is the K neighbors classifier, as the meta classifier to make the final prediction. And so for this are the stacking result. So when compared to its base classifier like the Bernoulli and the logistic regression, stacking classifier didn't perform well. So this might be due to its lack of diversity among the base classifier used. So the stacking relies on the diversity of the base classifier to capture the patterns and apply their respective strengths. If the base classifier and stacking ensemble is highly correlated, means the classifier but won't perform well from their combination, so it results in decreased accuracy. So in overall, we found that the voting ensemble method has outperforms of all the ensemble methods experimented, so it achieved a greater true positive rate while retaining a low false positive rate. So this indicates that it improves the classification performance. The conclusion of this experiment said is the voting ensemble method is the best performing model. Even the boosting, bagging, and also the voting improve the model performance compared to our baseline model. And usually the ensemble methods will be more useful in a complex data set where the single model might face some drawbacks. And in overall, the ensemble method provide higher accuracy, increase the robustness, and improve the generalization.